In this video, we're going to go over how to do the same things we did in Chapter 7. We're going to create a scatter plot. I'm going to show you the buttons to press to make sure we get the correlation coefficient, but we're going to go a step further. In Chapter 8, we're actually going to find the linear regression model and answer a ton of questions based on that model. All right, so this is going to be a pretty long example, but kind of cover the main issues that we're going to cover for this entire unit. Yes, we have Chapter 9. Yes, we have Chapter 10. But it's really just kind of a continuation or variation of what we're doing in this chapter. So this is the most important chapter in terms of understanding linear regression. So let's go ahead and get our calculator up. The first thing I always want people to do when you're doing linear regression is we're going to hit second 0, which is the catalog. And remember, like we did in Chapter 7, every time we do this, because most likely your calculator was cleared or you don't know who's been using it, if you're using a community calculator, you need to go to diagnostic on. We're going to push that button and turn it on. A little too far. I guess I can just hold it down next time. So diagnostic on and enter. So now when I do my linear regression, it will also give me my correlation coefficient. All right, so let's type in this data into list 1 and list 2. And this is talking about used Toyota Corollas for sale. So hopefully somebody in the class has a Corolla or drives a Corolla, or their family or someone they know owns a Corolla. Beautiful car. And so the question to ask in terms of which will be your X variable, which will be your Y, do you think the age of the Corolla explains the price, or do you think the price explains the age? Again, you could probably choose either one here. I'm going to say that the age of the Corolla is going to, no pun intended, drive the price. All right, so let's go and start typing these in. I'm going to put the age in list 1 and the price in list 2. All right, guys, so I've got them all in here for list 1 and list 2. I'm going to make it a little bit larger so you can see this. So the first step I'm going to do is I'm going to just create a scatter plot, right? You notice in your on your notes, we have a lot of things to answer, like talking about describing the association between the age and the price of a used Corolla in letter A. So let's go ahead and just do second stat plot. Let's turn our first one on. Let's turn it on. And then we're going to do this scatter plot. I'm using list 1 as my X, list 2 as my Y, so we're good to go. So I'm going to hit graph and then zoom 9, which is zoom stat. All right, so here we go. Now, remember, for describing the association between these two quantitative variables, you're thinking about direction, form, and strength. So direction looks negative, the form looks linear, and the strength looks, I'd say, pretty strong, right? Or I would say strong. I don't want to use those otherwise, but it looks strong. They're very, very tightly clustered. So I'm going to write here, I'm going to write for part A. All right, there is a negative, linear, and strong association between age and price of a used Corolla. Okay. Now, question B says, do you think a linear model is appropriate? So this first question that you ask yourself once you make the scatter plot for these two quantitative variables is, do you think it's appropriate to make a linear model, all right, a linear regression model? And in this case, all you have to do is say, if you decided that the form was linear, which we wrote linear for our form, then yes, it is appropriate to use a linear, or actually to make a linear model. So it is appropriate to make a linear model because the form is linear. Now, I'm going to answer a second question later on in this example where I ask, is it appropriate to use the linear model? So I know question B is pretty vague, but I'll make sure that you understand the difference here. Is like, first question is it okay just to make one? And the answer is yes, right? We said that the form was linear. So if you think, or if you write down linear for the form when you're describing the association, yes, it is appropriate to make a linear model. The second piece of this is having to check something that's called the residuals plot. And I'm going to get there in a moment. I'm not going to do that right now, but I'll kind of answer that question. And this is it appropriate to then use the model that you have just created? So let's go ahead and create the model, because that's the next step, really. All right, so to create it, we're actually going to do the same buttons we pushed for chapter 7. I'm going to hit stat. Now I'm going to hit calculate. I'm going to go to linear regression A plus BX, which is number 8. Hit enter. All right, so in list 1 are my ages, list 2 are my prices. Don't need to worry about frequency list. Now this one is interesting. Store the regression equation. You don't have to do this. There are some questions later on that ask me to actually use the model that we're going to create to predict a price for a used Corolla, like a specific one. So I'm going to actually just show you kind of the capabilities of this. So I'm going to hit, you see where it says vars. If you click vars and go over to yvars and hit enter where it says function, I'm going to put it into my function y1. Okay? So I'm just telling the calculator, okay, you're going to make this regression equation for me, and then I want you to put it into the equation for y1. Now I'm going to hit calculate. All right, now hopefully you notice some things, the same things from the last chapter, chapter 7. We got our correlation coefficient. I'm going to write this down over here, negative 0.972. Write this down over here. Let's see, so R equals negative 0.972. That confirms what I said earlier, right? I said earlier that the strength was strong, right? And an R of negative 0.972, which is really, really close to negative 1. That is definitely strong. All right. And let's go ahead and answer, we already answered part C. I could have just written it here. My bad. And then explain the meaning of R squared. So this is a new one from this chapter. So R squared, I'll write it down. R squared says 0.944. So R squared 0.944. Now, what you need to know in terms of getting this question correct on the AP exam is that the meaning of R squared is it describes the change in your Y variable that is explained by the change in your X variable. Right, so that's with no context. This is saying in context, right, in this context. So that would be that the change in the price of a Corolla, let me write out this, 94.4%. We always write R squared as percentages in our statements of the change in the price of a used Corolla can be explained by the change in age, so how old it is. All right, and 94% or 94, almost 94.5% is really close to 100. So we're saying that here that again, pun very much intended, the driving force for the decision on what whatever dealership or just person is selling a car, whatever they decide for the price for a car, the main factor is the age, which completely makes sense. If you don't know by now, and this is something I learned maybe in high school, college sometime, right? The moment you drive a brand new car off the dealership lot, it immediately loses value. Now that's very, very dramatic, right? But the idea is that you're paying for that premium for that brand new car. All right, so the moment you drive it off the lot, it starts to age, and the depreciation of these goods, these cars, is going to happen. So you're going to see the value decline. Okay, I don't think that's that surprising. So let's answer E. Why doesn't this model explain 100% of the variability in the price of used Corolla? So really on this, I'm saying, okay, are there other things that might change how much you could charge or how much you could price or list a price for a used Corolla that you could sell? So I think I've come up in the past of things like the condition, right? There are some cars that are older, but that are actually in better condition than newer ones. One thing I definitely know I've bought a used car before is the miles, right? We bought in 2017, we bought our van. Some of you have seen me driving around that van. A beautiful car. Gosh, I mean, just an amazing van. I'm lucky to drive it. We bought that car in 2017. It's a 2014. All right, so roughly 3 years old at that time, and it only had 14,000 miles on it. That's not a lot of miles, right? But if we had bought that car, that same exact car, but it had 50,000 miles, right, it would have been cheaper. Okay, so that's a part of this as well. And then I think the other one I came up with, I'll stop after this one, is the accident report, right? If it's been in, if the car that's been flooded or floated down the street during one of our many hurricanes, or if it's been in many car accidents, a lot of collision work, ultimately that could affect the price as well. Okay? All right, now let's go ahead and write down the equation of the regression line, which we have right here. I know in chapter 7, I kind of just breezed right by them. And in this one, it's time to bring them in. It's letter A and letter B. Remember, I'm using linear regression number 8, which is the y-intercept first. So 14,285.95. So 14,285.95 is the y-intercept minus, it's a negative slope, not bad, minus 959.05. 959.05. Now, I know that the calculator says like y, a, b, and x, but when you do this, when you use your y and your x, please, 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 go ahead and just write the name of the variable. So my x variable we said was age, right? So it's multiplying by age. And my y variable was price. All right, and I put this little hat on top to show you that this is called the predicted price. So now, if I wanted to use this model to predict, like say my friend down the street says, hey, I'm selling a used Corolla. I know you've been working with Corollas. Absolutely. How old's your Corolla? And if the person says 6 years old, I can type in or plug in 6 into age, and this model will spit out a predicted price that we should list the car at. All right, so again, I know this is a very simplistic thing that we're doing in this chapter, but this is what they do. This is an algorithm, a computer program, code that they've written at CarMax, Texas Direct Auto, all these places that sell used cars. They're essentially using a more sophisticated version of what we're talking about right now. Okay, so let's explain the meaning of the slope. Let me do it without context. The meaning of the slope without context, and this is really good because you saw this a couple years ago in Algebra 2, that for each additional 1 unit of x, we expect the y value to change by the slope. So let me write it in context. So for each additional year, I expect the Corolla to decrease in price by $959.05. Again, this is just an expectation based on this model, which makes sense. We think that car prices will go down as they depreciate, so we're saying we expect it to go down by almost $1,000. Now the y-intercept. The y-intercept with no context is for an x value of 0, right? If you plug in 0 for your x, then the y value is your y-intercept. So in this case, we would say for a 0-year-old Corolla, which is just a weird way of saying, right, brand new, I expect the price to be, and this is where you're going to write your y-intercept, $14,285.95. Okay? Now, sometimes the y-intercept will make sense. This one kind of makes sense, right? A 0-year-old Corolla is a brand new car, so we're expecting the brand new Corollas to cost just over $14,000. But sometimes they will make no sense, and so we just kind of rewrite it and think, oh, this doesn't make any sense. Okay. Now, let's go ahead, and I'm going to take a pause here before we do this last slide. Because this is now using the model. And I want to go back to what I mentioned about these two different things really with question B. First, is it okay just to make the model? We said yes, because we said it was linear in the scatter plot. And now the question is, can we use it? So here's something new. What we do is we check the residuals plot. And this is something you'll have to not necessarily do on the AP exam, but you will need to understand what you're doing and why you're doing it. They'll be asking questions for sure about residuals. All right, so I want to, what I'm going to do is once you do this linear regression, right, see how I did it? It immediately has, the computer, what it's done is it's taken all of our ages, right, all of the values for our x values in list 1, and it's plugged it instantaneously into this model and found out what those values would be. All right, so here's what I'm going to show you. If you go to stat, and let me do this first and go to edit. Actually, no, look at y equals. So you see how I told it to put the linear regression model into y equals. So when I graph this scatter plot now, you'll see, oh my goodness, there is our model. Sick. Now, do you see how some of the squares are above and some of the squares are below the line? And actually, some of them look like they're almost on the line. That difference between the actual price of these Corollas and what the model is predicting it to be is called the residual. All right, so we'll get into it, but residuals, which you'll memorize, the actual way to calculate it is the observed value, so what you actually have in your table, minus the predicted value, so what the model thinks it should cost. That is called a residual. So those squares that are above the line have a positive residual. Those squares below the line have a negative residual. So here's what we're going to do. I'm going to go to stat. I'm going to try to see if I can sort this for your brain, and edit, and go to list 3. All right. And what I'm going to tell it to do is I'm going to tell it to plug in all of these x values into the model, which I stored in y1. So watch this. So I'm going to hit second. Actually, no, I'm just going to hit straight up vars, not second vars, just vars. Go over to y vars, function, y1, and then do parentheses and hit second number 1, which says list 1. So I'm saying take all the values in list 1 and put it into our model. And boom, these are all those predicted values. So if you look at list 2 to list 3, 13,990 minus 13,327, that would be a positive residual. So now watch this. This is the coolest part. So go to list 4, scroll up to list 4. Now I'm going to hit second stat, which is list. And if you go to number 7, it says resid, which is residuals. Click number 7. I'm going to tell the calculator to put the residuals in this list, list 4. And look at that. It's what it's doing, right, or what it already did for us, is I'm showing you now it's taking list 2, subtracting list 3, that's the predicted value, and getting list 4. All right, so you can see some of the residuals are positive, some are negative, some are really close to 0, some are not close to 0. Again, if your residual is 0, that means you're selling this Corolla at exactly the price that the model thinks you should. All right, so now that was a long way of saying, let's actually go and check to see what the residuals look like. And this is kind of the main thing. So you can do a couple of ways. I just put my residuals into list 4, or you could just put here the residuals list. I'm going to do that. Don't change the x values. Leave the x values, which are in list 1, as the x value. So hit second list and go to go to residual, number 7. All right, so now I'm going to hit graph. And then I'm going to take that line out of here so you're not worried about that. So let's take this line out. You just go over to the equal sign and hit enter. So now we'll graph it. Then go back to graph and hit zoom 9. All right, so this is the residual plot. Now here's what we're hoping to see. The whole idea is that in theory, we want our linear regression model to capture everything that's going on between these two variables, okay? So if that's true, then what we expect to see in the residuals plot is we expect to see, I want to say this in air quotes, nothing. I expect to see a cloud, no pattern, nothing whatsoever interesting going on. So I'm hoping to see just random dots in a cloud, no pattern. All right, we'll talk in class about patterns you might see. So in this case, it kind of looks to me like there's no pattern, right? You could probably argue that there might be, but I just want to keep going with this. So I'm saying that this residuals plot shows no pattern. It's just a cloud of random squares. So because there is no pattern in the residuals plot, it is appropriate to use the linear model. All right? So that's kind of the second check you have to do before you actually end up using it. Now, we'll talk about in Chapter 10, which is literally all Chapter 10 is devoted to, is what happens when you look at the residuals plot and boom, it's not appropriate. You see a very distinct pattern, a distinct curve or bend, right? So we'll talk about what to do if that happens. Okay, now let's go and answer these last questions and we'll be done. So if you want to sell a 7-year-old Corolla what price seems appropriate. So the way we do this is we do price hat equals, and it was, I think, 14,285.95 minus 959.05, and I'm plugging in 7 for my age. Now, again, this is the kind of cool thing. We stored it. If you just go to second quit and you hit stat, or sorry, don't hit stat. You just hit vars and go to yvars function, and you hit y1 parentheses, and you plug in 7, it will spit out what it should be. All right, so $7,572. So the price, again, I'm putting this hat here to show it's predicted, right? I'm not saying it's actually going to cost that. So $7,572.63. Okay. Now, again, if you forget to store it, right, you just type in all this stuff and times 7. So it's not like a huge time saver, just something cool the calculator can do. Would you rather buy a used Corolla with a positive or negative residual? Oh, so here we go again. Residual equals observed. So what's actually happening minus what the model is predicting. Okay. Now, I just tell kids just to make up some numbers to kind of sort this out, or you can just kind of think about it in your head. But I think making up numbers makes the most sense. But if I buy a car that has a positive residual, then the observed value must be greater than the predicted value. So that means I'm paying a certain amount of money for this car, and the model thinks I should be paying less. That's not what I want, right? I want the other scenario where what I'm paying, like what I'm actually paying to buy this car, is less than what the model thinks I should be paying. So that would actually become a negative residual. All right, so I want to have a negative residual because that means I, the consumer, am getting a deal. I'm paying less money than what the model thinks I should be. Okay, you see a for sale sign on a 10-year-old Corolla stating the asking price is $3,500. What is the residual? So here we go. So residual, remember, is observed minus predicted. So it's $3,500 is the observed, right? That's what they're actually seeing for sale, minus, and I'm going to go to the calculator, and I'm going to type in that same thing. So hit vars, function, y1, all right, and I'm going to do, this time I'm doing 10 years old, which is 4695.49. 46. Let me confirm. Excellent. So now I do 3,500 minus that, and this will give me my residual. So negative $1,195.49. All right. So again, as I mentioned in the previous question, this would actually be a good deal for the consumer who buys this because you're paying $3,500, but the model thinks you should be paying over $1,000 more than that, almost $1,200. Would this regression model be useful in establishing a fair price for a 20-year-old car? Now, this is a concept that we'll talk about in this chapter. If you go back to all your data values, right, the youngest car was a 1-year-old car, all the way up to the oldest car, which is a 13-year-old car. So anything that is not in that range of your X values, I know it's weird to say range in X, but we're not in algebra class, but anything that's not between 1 and 13 years old for these cars would be what we call extrapolation. So it's not appropriate to use this model if you're talking about going further in either direction, right? A lot of students think it's always going to be greater than, that's what I'm talking about. No, it could be the other direction. So essentially what I'm saying is no, because this is extrapolation, which I'm not saying you can't do it, but you just want to be cautious if you're talking about using extrapolation. All right, I know it's a very long video. Watch it, in whatever speed, chunk it however you want, but make sure you're practicing doing all these types of things on your own with the calculator. This is a really good example that covers pretty much everything you'll need to know from Chapter 8. Good luck.